So as I make this section, I watch this massive law enforcement drill taking place over these supposedly escaped prisoners. It's quite the fiasco show. But right now, and I mean, it plays in because again, it's all part of the programming. It's all part of perception management, and all these communities involved in this drill, are acceptant of the massive lockdown of their communities in the name of hunting these two men, and that may or may not even exist. Um, so keep that in mind as we continue throughout this, as we've gone through this little series here. Now, this is to give you a concept and idea of infinity. Okay, and also it plays into part of the light and rainbow holographic world you live in dealing with images, being that whether it's image, smell, a feeling, a touch, your five known physical senses, um, ultimately are all just like in the Matrix movie, which was full of tons of analogy, metaphor to explain these concepts, um, which we may use some of them here. But it's only what you're seeing in regards to how you're processing the information is nothing but electrical responses going on, computing basically, to process the images into what you appear to see or feel or smell, etc. It deals with all senses, all points of observation. So this is the infinity mirror, and an infinity mirror is a set of mirrors, one fully reflective mirror and one one-way mirror, set up so that the one-way or partially reflective mirror reflects an image back into the fully reflective mirror in a recursive manner, creating a series of smaller and smaller reflections that appear to recede into an infinite distance. This effect is also seen when a subject stands between two fully reflective mirrors, as in a changing room or house of mirrors. In the classic self-contained infinity mirror, a set of light bulbs, LEDs, or other point source lights are placed in a periphery of a fully reflective mirror, and a second partially reflective one-way mirror is placed a short distance in front of it. When an observer looks into the surface of the partially reflective mirror, the lights appear to recede into infinity, creating an appearance of a tunnel of lights of great depth. The explanation of the effect and the reason why the reflections recede into the distance is that the light actually is traveling the distance it appears to be traversing in a 2-inch thick infinity mirror, with the light source itself in a 1 inch from the front of the two-way mirror. Light from the source only travels that 1 inch. The first reflection travels 1 inch to the rear mirror, and then 2 inches to and through the front mirror, a total of 3 inches. The second reflection travels 2 inches from the front mirror back to the mirror, again to 2 inches from back to mirror. And this is just this right here. It's what they're talking about here. It's kind of in different to our example here. I just wanted the basic definition for you. Now this is another place. These things come to me when they come to me, and how they come to me. I usually do not really have to search for this stuff. I know what I'm looking for, and so I find it, and I have a great gift of synchronicity to the Lord gives me what I need when I'm needing it. So I'm not going to read this whole blog though, but infinity is weird, even in infinity mirrors. Even very simple optics can reveal very interesting and surprising phenomena if one looks carefully enough. I was recently looking into the optics of so-called infinity mirror, which is, in its simplest incarnation, is simply two parallel mirrors on opposite sides of a room or elevator or whatever in space, and the result is multiplication of images seemingly stretching out into infinity. And here's his example. First of all, I started mulling over the nature of the images, assuming one could see of all the images in an infinity mirror all the way to infinity. Would their total apparent area be finite or infinite? And this goes on to start talking about some mathematics that he did. And again, the link will be in the box. You can read the whole thing. We're going to screw down here for a bit and get to the point of I want to bring in the harmonic series diverges. We, similarity, because it's comparable to the harmonic series, and combined width of all images basically is what he's discovered here through his mathematics, is that the up and down vertical is finite, but the wide view or whatever, we therefore have an unusual situation. The combined area of all the images in an infinity mirror is finite, but the combined width of all the images is infinite. So this mathematical peculiarity is closely related to a geometric object known as Gabriel's horn, pictured below. And this is the point, kind of. This horn, which extends off infinitely to the right, is an object with infinite surface area, but which encloses a finite volume. To see the connection to our infinity mirror images, let us label the radius of the horn y and the length x. They're going to go on with some more mathematics, but basically the odd properties of Gabriel's horn were first studied by Italian mathematician Evangelista Torricelli in 1608-1647, is also known as Torricelli's trumpet. And to understand how truly weird this mathematical object is, it could be filled with a finite amount of paint, but it would be impossible to completely decorate the outside of the horn with this paint, no matter how thin a coat. Of course, we cannot make a infinite version of Gabriel's horn, and similarly, we never see an infinite number of images in an infinity mirror. The images either drift off the visible surface of the mirror after a finite number of repetitions, or become too dim to see. Less and less light contributes to the more distant images. Okay, the lesson here, I suppose, is that unusual mathematics can be found even looking at relatively simple physical phenomena such as an infinity mirror. The secondary lesson is that weird things happen when one considers problems involving infinity. Now, okay, so we take this knowledge, that knowledge, okay, and just hold on to it with what we've already discussed in the previous issues of this series in the volume. Now this is from the Scientific American. It's called "What is the Casimir Effect?" And Northeastern University experimental particle physics Stephen Rowcroft and John Swain put their heads together to write the following answer. To understand the Casimir effect, one first has to understand something about a vacuum in space as it is viewed in quantum field theory. Far from being empty, modern physics assumes that a vacuum is full of fluctuating electromagnetic waves that can never be completely eliminated, like an ocean with waves that are always present and can never be stopped. These waves come in all possible wavelengths, and their presence implies that empty space contains a certain amount of energy, an energy that we can't tap, but that is always there. Now, if mirrors are placed facing each other in a vacuum, some of the waves will fit between them, bouncing back and forth, while others will not. As the two mirrors move closer to each other, the longer waves will no longer fit, the result being that the total amount of energy in the vacuum between the plates will be a bit less than amount elsewhere in the vacuum. Thus, the mirrors will attract each other, just as two objects held together by a stretched spring will move together as the energy stored in the spring decreases. This effect, that two mirrors in a vacuum will be attracted to each other, that is the important part of why I'm reading you this, that is called the Casimir effect. It was first predicted in 1948 by Dutch physicist Hendrik Casimir. Steve K. Lemeru, now at Los Alamos National Laboratory, initially measured the tiny force in 1996. It is generally true that the amount of energy in a piece of vacuum can be altered by the material around it, and the term Casimir effect is also used in this broader context. If the mirrors move rapidly, some of the vacuum waves can become real waves. Julian Schwinger and many others have suggested that this dynamical Casimir effect may be responsible for the mysterious phenomenon known as sonoluminescence. Okay, one of the most interesting aspects of vacuum energy, with or without mirrors, is that calculated in quantum field theory, it is infinite. To some, this finding implies that the vacuum of space could be an enormous source of energy called zero-point energy. But the finding also raises a physical problem. There's nothing to stop arbitrarily a small waves from fitting between two mirrors, and there is an infinite number of these wavelengths. The mathematical solution is to temporarily do the calculation for the finite number of waves for two different separations of the mirrors, find the associated difference in the vacuum energies, and then argue that the difference remains finite as one allows the number of wavelengths to go to infinity. Although this trick works and gives answers in agreement with the experiment, the problem of an infinite vacuum energy is a serious one. Einstein's theory of gravitation implies that this energy must produce an infinite gravitational curvature of space-time, something we most definitely do not observe. The resolution of this problem is still an open research question. And so I will again include the link to this, and we'll add this to our repertoire of information that we just have acquired through these videos I have thus far created. So, and I don't know how much time I have to add on to this, or if I have to continue on, but in continue on I will just discuss some examples of how this mirroring effect is the uncertainty principle of what is, or can be used as a model of the uncertainty principle of the infinite amount of choices in every infinite moment that a person can make, that then can therefore change the path. Now, of course, in the I know in the occult and in reference, and you've been shown in movies, Disney does it a lot. There's a lot of different where they portray mirrors with powers, with the magic mirror, mirror on the wall, all that, other things. There's Disney does it a lot because they know that the mirror is actually a portal and can be in the quantum aspect of itself. And we'll get into that in our examples, but you need to keep that in mind here. And I'll just give this bit to you at this point until we carry on, that basically when you're looking at the infinity mirror and you're seeing the copies of yourself, the reflections of yourself going into infinite, when you're doing that, you are actually literally, because of the power we have already learned that observation is creation in quantum theory, okay, and quantum mechanics. And so therefore, when you're sitting there observing yourself in the two mirrors, stretching off into infinity into both directions of you, you are looking at the direct reflections of yourself in the direct dimensional fractal element right next to your own path at the current time, because all the representations of yourself in this in the uncertainty principle point are going to be right there in a lot. The ones you can see within your distance are going to be ones that are very similar to yourself in the choices that they would have made. Only slight differences would have remained and slight choices that they would have made. So you're not going to be sitting there basically staring at your evil self that could be clear on down the infinite line of a path that you, a timeline that you chose not to take. And we'll get more to that in the next section. I don't know how much time I got on this, so. Yeah, okay, so we've got about a minute left, so in the next issue here, we'll get to some examples. I'll give you basically some examples of the perception management and how they've used it, and also the further expression on your the multidimensionality of the quantum world that you actually live in, and how what you see around you is really nothing but energy signatures until you actively engage that energy signature. Does it then become manifest into your reality? And we'll get more into this, and like I said, in the next issue. So thanks for watching. I hope you join me when I get the next one pumped out here.